Welcome to the Ham Radio Nomad. Um, we are going to be doing study questions again. Um, I failed miserably at the last test, so I think I need to do some talking over with Steve. I haven't seen very many of the questions, so I'm going to go back and do some more study questions. So let's try these. Let's go and check some more study questions. So question C11, and if you want to comment on the questions, just go ahead and refer to the code up here, E1C11, to know which one you are referring to. So starting out, which of the following operating arrangements allows the FCC licensed U.S. citizen to operate in many European countries and alien amateurs from many European countries to operate it in the USS? A, all of these choices are correct. B, the ITU reciprocal license. C, IARP agreement. D, SEPT agreement. I'm going to go with SEPT. I believe IARP is for the Americas. Yep. Conference of European, SEPT. E3A14. What is meant by circular polarized electromagnetic waves? Waves with an electrical field bent into a circular shape. B, waves produced by a loop antenna. C, waves that circle the Earth. D, waves with a rotating electrical field. And just for all those that are watching and those watching on Team Replay, please, as you see in the banner, be sure to hit that like and subscribe button. Also, click on the notification bell to be alerted when I do live stream. I do mostly live streams, so make sure you hit that notification button so you can get alerted when I go live. Hi, Cody. Welcome to my study session. And someone else just stepped in. Just make sure to hit the like and subscribe, and let's continue with question 2. What is meant by circular polarized electromagnetic waves? And I am going to say A. And actually, now that I read it again, it's D. Yeah, it's waves with a rotating electrical field. Which of the following is an aspect of piezoelectric effect? A, mechanical deformation of material by the application of voltage. B, generation of electrical energy in the presence of light. C, mechanical deformation of material by the application of a magnetic field. D, increased conductivity in the presence of light. Okay, it's talking about electric, so C's out, and both D and both B and D are okay. I know it's not B. That's photoelectric. And yeah, I'm going to go with deformation by because of the application of voltage. Yep. Yeah. It does. It's not. If it was the ones that are light and electricity, B and D, um, are photoelectric and photovoltaic. Welcome, Temporary Offline, and Smoking Ape. You are back. Thank you. The Baofeng very well might be um, the most popular radio. I am actually wanting to borrow someone's Baofeng and do a comparison video on the Baofeng and my Wuxum UV 9D. I just actually that's a spoiler for another video. So my first HT. I want to do a comparison with other people's first HTs, which is typically the Baofeng. So, and Cody asked, I am new to the ham radio stuff. I will tell you right now, Cody, these are the amateur extra questions. They are very advanced. So do not be scared away by not knowing this. And if Temporary Offline and Smoking Ape, I don't know if either of you are still in the chat. Could one of you grab a video? If you could try to grab a video to grab one of Josh's HRCC's videos for Baofeng setup. If not, I will, Cody, check back and I will put it in the comments below once I get done with the video. I will link in the comments to one of Josh's videos. E9H10. How can the output voltage of a multi-turn receiving loop antenna be increased? I've seen this on the last couple tests, so I am just going to go straight to B, increase the number of turns and or the area. What is the process of normalizations in regards to a Smith's chart? A, reassigning. Thank you, Smoking Ape. Cody, there is the link. Yeah, so hopefully he will check back, and I don't think he's online anymore, but yeah. Thank you. Some more, Smoking Ape. What is the process of normalization in regards to a Smith's chart? A, reassigning resistance values with regard to reactance axis. B, reassigning impedance values with regards to the prime center. C, reassigning prime center in regards to the reactance axis. D, assigning the reactance value with regards to the reactance axis. So this one is, so I believe I chose C last time, reassigning the prime center, and it is actually the opposite. So it is, I believe it is B, reassigning the impedance values with regards to the prime center. So it's the only one in normalization, it's the only one that is in regards to the prime center. Hello, ham radio dude. Okay, not a problem, Smoking Ape. Yep, I am aware of um of Josh's, but yes, you and actually ham radio dude both have um Bofeng videos as well. So not a problem. Thank you. How is forward error correction implemented? A, by varying frequency shift of transmitted signals according to a predefined algorithm. B, by transmitting extra data that may be used to detect and correct transmission errors. B, by transmitting a special algorithm to the receiving station along with data characters. B, by the receiving station repeating each block of 3 data characters. And I'm going to guess that it's B. Yeah. And the reason why I picked it is because it's forward error correction. So I'm saying it's being proactive. And this is the one about saying extra data to correct the transmissions. And I believe it is actually also the only one that has both correction and correct. Correction in the question and correct in the answer. And I have noticed that repeatedly on the advanced is if there are common words in the question and an answer, more than likely that is the case. Yeah, Smoking Ape, I got it wrong the first time, that one wrong the first time too, and it's just, I've been doing this week over week that I'm starting to get the same questions back again, so I'm sort of remembering those. And dope, watching a lot of The Simpsons there. E2C12. What technique do individual nodes use to form a mesh network? A, acting as a store and forward digipeaters. B, forward error correction and vertibie codes. C, discovery and link establishment protocols. D, custom code plugs for local trunking systems. So I am, I'm thinking it's either A or C. I'm gonna guess A. Nope. C. And that, I think, was my biggest fault on the, sorry about the camera. The biggest fault when I was taking the test is I could narrow it down to the top 2, and then I chose the wrong one. Yeah. So mesh networks are 0 or little configuration, so they have to be able to discover each other and establish links to new nodes. What is receiving directivity factor, RDF? A, forward gain compared to average gain over the entire hemisphere. B, relatively directivity compared to dipole, C, directivity compared to isotropic, D, forward gain compared to the gain in the reverse direction. And there are two that have directivity but from the question. So I'm going to narrow it down to those. And then I am going to go that isotropic, I believe, is ideal. So I'm going to go with that it's compared to isotropic. And I am wrong on both accounts. So it is A, forward gain compared to average gain over the entire hemisphere. And that would probably be, I think okay. Yeah. So that's where this is, it's also called the relative directivity factor. And relative would emphasize that it's forward gain compared to average. How many watts are consumed in a circuit consisting of 10 ohm resistor in series with 10 ohm inductive reactance drawing 1 amp? Okay, so reactants or resistors and are added, so that's 200 ohms total and 200 ohms with Ohm's law. So 200 ohms times 1 amp should be 200 watts is what I'm going to say, and I am wrong. So only resistance. Okay, so the resistor has it. Reactance doesn't actually consume power, so it is ignored. Okay, that's what I missed. It slows the flow, but it does not actually consume power. So okay, E6, E8. What or how is power supplied to the most common type of MMIC? A, MMICs require no operating bias. B, directly to the bias voltage, VCCN lead. That's what I chose last time. Then I got it wrong. Hello, Gordon. Welcome to my study session. I am going through study questions again since I did so poorly last week. So I need to do some more studying. So I know B's wrong because I did that last time. A's not right. So it's either C or D. C, through a resistor and or RF choke connected to the amplifier output lead. D, through the capacitor and RF choke connected to the amplifier input lead. I'm going to say it seemed a little odd that I would think it's going to be input, but it seemed odd when I read the question. So I'm actually going to say that's the output. And yes, that is correct. Good luck on your taking the test on Thursday. It would be great if you comment below on Thursday and let everyone know how the test went for you, Gordon. I would love to hear about it. E5CO8 or C0, and I'm getting everything mixed up. C09, not 08. When using rectangular coordinates to graph the impedance of a circuit, what do the axes represent? A, the x-axis represents the reactive component and the y-axis represents the resistive component. B, x-axis represents the resistive component and the y-axis represents the reactive component. C, x-axis represents the magnitude and the y-axis represents the phase angle. D, the x-axis represents the phase angle and the y-axis represents the magnitude. So from the other one that I keep getting wrong, I'm going to guess that it is typically coming up this way, the resistance, and then it's the up and down that is a reactive component that I keep getting wrong. So I'm going to go with B. X-axis is the resistive component and y-axis is the reactive. And that is correct. What is the most common data rate used for HF packet? A, 300 baud, B, 110 baud, C, 48 baud, D, 1200 baud. I picked 1200 baud last time and I believe it is 300 baud. Yep. Which amateur stations may be operating under RACE's rules? A, any FCC licensed station except a technician's class. B, only club stations licensed to amateur extra class operators. And I know both of those are incorrect because RACE's is not per class or per license. So it is either C or D. C, any FCC licensed amateur station certified by the responsible civil defense organization for the area served. Or D, any FCC licensed station participating in Mars. Okay, RACES doesn't have anything to do with Mars, so that's also out. So it must be C. Yep. What is trans-equatorial propagation? A, propagation between points located on the magnetic equator. B, propagation between points on the equator and its antipodial point. C, propagation between points at the same latitude. D, propagation between two mid-latitude points at approximately the same distance north and south of the magnetic equator. And that is correct. What is included in the total resistance of an antenna system? A, radiation resistance plus loss resistance. B, radiation resistance plus place impedance. C, transmission line resistance plus radiation resistance. D, radiation resistance plus transmission resistance. And I am going to go with C. It's a transition line resistance plus the resistance of radiation. And I am wrong. Okay, so it's radiation resistance plus loss resistance. Okay, so that would make sense because so we have the radiation resistance, and then we have any loss that could be from transmission line, or it could be from um, the lost resistance due to bad SWR would be another resistance loss, and that would cause it's not in the transmission line, it's in the antenna itself, and that would cause cause the antenna to heat up and give additional loss. How many horizontal lines make up FastScan NTSC television frame? And that would be 30, and it's a frequency. Okay. Okay. It's 30 frames per second. Each frame is 262.2 262.5. So 552 per second. That doesn't. Okay, so it's 30 frames per second. Each frame has two fields for a total of 525 per frame. $843 are visible, and the rest for synchronization and retrace. Yeah, that's one I've gotten. I usually get wrong. What is the current in the primary winding of a transformer called if no load is attached to the secondary? So I got this wrong the last two times. So it is magnetizing. It's basically taking it is taking the electricity and inducing a magnet in the core as it waits for a load. It waits for a load on the secondary. At least that's how I'm thinking about it. Oh, Pierce isolator again. How is positive feedback supplied in a Pierce uh, isolator? A, through the neutralizing capacitor. B, through the quartz crystal. C, through the link coupling. D, through the tapped coil. And it is through the quartz crystal. And yeah. And yeah, the dumb tip, it's dumb, but um, it was what I remembered. Is it's the only answer was something that could pierce you, where all the other ones are capacitor, coupling, coil. It's a crystal is can be sharp and could pierce you. So it's stupid, but even if this some of these things don't really make sense, it's silly and it can help you remember. How E9D02. How can linearly polarized Yagi antennas be used to produce circular polarization? A, arrange two Yeagis perpendicular to each other with the driven element at the same point on the boom fed 90 degrees out of phase. B, stack two Yeagis fed in phase to form an array with the respective elements in parallel planes. C, arrange two Yeagis collinear to each other with the driven elements fed 180 degrees out of phase. D, stack two Yeagis fed 90 degrees out of phase to form an array with respective elements in parallel planes. So this is a other question. So that is the study sheet for phase for antennas in phase, but that is for verticals, and this is for Yeagis. So I don't know. So it is for a circular polarization, put them perpendicular, same point on the boom, fed. So it's perpendicular, and then you want it 90 degrees out of phase. So, okay. So it's basically you're taking the driven elements, rotating them 90 degrees to make them perpendicular, and then you do this, and then you do the same thing with the phase. When evaluating a site with multiple transmitters operating at the same time, the operator and the licensees of which transmitters are responsible for mitigating overexposure situations. A, only the most powerful transmitter. B, each transmitter operating with a duty cycle greater than 50%. C, each transmitter that produces 5% or more of its MPE limit in areas where the total MPE limit is exceeded. D, only commercial transmitters. I'm going to guess C. Yep. And that being said, the reason I did that is because B made more sense to me. But last time I got it wrong because I picked the one that made more sense to me. So I picked the one that didn't make as much sense. It works. It's how my mind thinks sometimes. E9C04. What happens to the radiation patterns of a unterminated long wire antenna as the wire length is increased? A, front to back ratio decreases. B, vertical angle increases. C, lobes align more in direction of the wire. D, the lobes become more perpendicular to the wire. So a long wire being lengthened, I believe will change the shape towards in-fed half wave. And I believe that the in-fed half wave is the lobe is in direction of the wire, so I'm going to go with C. Yeah, I believe the lobes of an in-fed half wave is follow the direction of the wire. So that is why the answer is C, and that's when you lengthen the wire length, it's becoming more like in-fed half wave. What is the main reason to use a charge controller with a solar power system? If I get this one wrong, that is not good because I am sitting in my van with a solar system on top and a charge controller beneath me. So, and I'm so A, prevention of battery damage due to overcharge. B, prevention of battery undercharge. C, matching time and night change rates. D, control of electrolyte levels during battery discharge. And it is A. Charge controller slows down and or stops the voltage coming in from the solar panels so that the batteries do not become discharged or not overcharged. E7D11. What is the function of pass transistors in a linear voltage regulator circuit? A, maintains near constant output impedance over a wide range of load current. B, provides stable input impedance over a wide range of source voltage. C, prevents a wide range of output voltage settings. D, maintains near constant output voltage over a wide range of load current. Okay. I'm going to guess D. So, yeah. The output is what's typically important in a linear voltage regulator. So that's the ones that I was looking at, and this one made the most sense to me. So, what is the minimum passing score of all amateur operator examinations? Well, good thing we had this discussion in the Toads Discord, which if someone wants to put that in the chat, that would be great timing. If you watch my previous videos, I very publicly said, "Oh, I'm 3, 2, and 1 point away from passing." Unfortunately, I thought passing was 70%, and I would have chosen B. But thanks to the Discord, um, we had this discussion, and the actual minimum passing score is 74%. Another reason why I'm taking tests is because I was even worse than I thought. So D, 74% is the minimum passing score. In the antenna radiation pattern shown in figure E9-1, what is the front to side ratio? A, 24 dB, B, 14 dB, C, 12 dB, D, 18 dB. So it is, forward is in reference to about 25 degrees. So we're looking at right at the 3 level. So we're looking at -3 right here. And then the side ratio is just above 12. So that's the one I'm going to go with, is C12. And that is wrong. Okay. So they're going on this one, they want all the way to zero, all the way out to the peak. And then just past 12 will give you 14. What does space weather term G5 mean? A, waning sunspot numbers. B, very low solar activity. C, extreme geomagnetic storms. D, moderate solar wind. And I believe G5 is really bad geomagnetic storms. Yep. How can linearly polarized, okay. So we just did that one. Okay, so the same radiation pattern of E9-1, but this is what in the radiation pattern shown, what is the beam width? This is where I'm going to go with 25 degrees. Okay, 25 on either side, so 50 total. The beam width is at 3 dB. What is the significant voltmeter sensitivity expressed in ohms per volt? A, when used as a gravimeter, the reading in volts multiplied by the ohms per volt rating will determine the power draw by the device under test. B, when used as an ohm meter, the reading in ohms divided by the ohms per volt rating will determine the voltage applied to the circuit. C, when using an ammeter, the full scale reading in amps divided by ohms per volt will determine rating will determine the size of the shunt needed. D, the full size reading of the voltmeter multiplied by its ohms per volt rating will indicate the input impedance of the voltmeter. Okay, so if you take the ohms and divide by the ohms per volt, I believe the ohms cancel out, so you're left with volts. So I'm going to pick B, and I am wrong. Okay. So yeah, ohms per volt, volts. Okay. And the volts cancel out. That's where I got messed up. So the volts cancel out in this one, and all that's left is the ohms, which is the impedance. And just a hint that someone gives, all the when used as answers are incorrect. And again, and this is the one that should have caught it, is common, both voltmeter, both in the question and in the answer. And yeah, I brought that up earlier today. If they have common words in the question and the answer, that's uh, usually usually the right answer. Tropospheric propagation of microwave signals often occurs in association with which phenomena? A. Gray line. B. Lightning discharges. C. Spirits and jets. D. Warm and cold fronts. Okay, talking about microwave signals, gray line phenomenon is HF. Lightning discharges, lightning just messes up everything, so I doubt that. And I'm going to go with spirits and jets. Nope, it's warm and cold fronts. So tropospheric is warm and cold fronts. And see what they have to say. Tropospheric propagation occurs when a difference in refractive indices in two adjacent pockets of air. What aspect of receiver analog to digital conversion determines the maximum receive bandwidth of a direct digital conversion SDR? A. Processor latency. B. Sample rate. B. Sample width in bits. D. Sample clock phase noise. And it's either, I believe it's either B or C. And I am going to go with, let's go with B. Yep. What is the triangulation method of direction finding? A. Antennas heading from several different receiver locations are used to locate the signal source. B. Fixed receiving stations plot three headings to the signal source. C. Fixed receiving stations use three different antennas to plot the location of the signal source. D. Geometric angles of skywaves from the source are used to determine its position. These have fixed receiving, so it is, you want different receiving locations. What type of computer program technique is commonly used for modeling antennas? A. Method of moments. B. Mutual impedance analysis. C. Calculus differential with respect to physical properties. D. Graphical analysis. I'm going to guess mutual impedance analysis. Nope. Yeah, method of movements. And What is a truth table? A table of logic symbols that indicate the high logic states of a op amp. B, a list of inputs and corresponding outputs for a digital device. C, a diagram showing logic states when the digital device output is true. D, a table of logic symbols that indicate the logic states of a op amp. I am leaning towards a diagram showing logic states when device output is true, because that's what we want is when things with a truth table is when things are true. And I am wrong. Okay, it is not just only the true ones, it is all of them. A list of inputs and corresponding outputs. So they want the truth table has all the inputs and outputs, not just the when output is true. Okay. What frequencies are authorized to an amateur station operating under RACES? A, Mars. B, specific local government channels. C, all amateur service frequencies authorized to the control operator. D, specific segments in the amateur service, MF, HF, VHF, and UHF. And whether you're operating under RACES, Aries, doing stuff for contests, everything is determined by what your license says you can do. So I'm going to go with C. What is a common method of generating an SSB signal using digital signal processing? A, signals are combined in quadrature phase relationship. B, frequency synthesizer removes unwanted sidebands. That's what I guessed last time, so I'm not going to pick that. I'm pretty sure that one's wrong, if my memory is correct at least. C, mixing products are converted to voltage and subtracted by adder circuits. D, varying quartz crystals characteristics emulate in digital form. I am going to go with the one that refers to digital signal processing and digital form. So I'm going to go with D. No, wrong. Okay. Signals are combined in quadrature phase relationship. How can conducted and radiated noise caused by an automobile alternator be suppressed? A, by installing a noise suppression resistor and a blocking capacitor in both leads. B, by installing a high pass filter in series with the radio's power lead and low pass filter in parallel with the field lead. C, by installing filter capacitors in series with DC power leads and blocking capacitors in field leads. By connecting the radiator's power leads directly to the battery and by installing coaxial capacitors in line with alternator leads. Okay, don't believe that one. I'm going to go with the high pass filter and the low pass filter. Nope. By connecting the power radio's power leads directly to the battery, and by installing coaxial capacitors in line with the alternator's leads. So, okay, last question. What transmit frequency might generate an image response in a receiver tuned to 14.300 megahertz and uses uh 4 455 kilohertz IF frequency? Input filter. So that one's too high. I'm going to go with that one. Nope. Image signal response is located at the tune frequency plus 2 times the intermediate frequency. Okay. So thank you for watching the questions. I am going to wrap it up since it is time for um, Ham Radio 2.0's 6 years on YouTube live stream. And he should be going live pretty much now. So wrapping it up, 73 to all. Take care and remember to hit the like and subscribe button. So 73 to all until I talk to you again. Take care.